Exercise 8F.2. A home entertainment system costs $12,500 to buy and decreases in value with reducing balance depreciation of 20% each year. A recurrence relation that can be used to model the value of the home entertainment system after n years, Vn, is shown below. Write down the rule for the value of the home entertainment system after n years. So this will be Vn is equal to, and we've got the R value there, that's the 0.8. So this will be 0.8 to the power of n times by 12,500. By the way, you may have noticed in the last couple of examples I've put brackets around the R value. You don't have to. It makes things a little less ambiguous, so that's all. I don't think you'd end up getting penalized for not putting brackets, but it's a nice habit to keep. Use the rule to find the value of the home entertainment system after 8 years. Write your answer correct to the nearest cent. So this is going to be V8, and this is going to be 0.8 to the power of 8 times by 12,500, which is equal to 2,097.15. Fun fact, you can also double check that on the CAS as well using the sequences option. Calculate the total depreciation of the home entertainment system after 8 years. So what does that mean? Well, what that means is that I need to go and take the initial value, subtract it by the value after 8 years to find out how much is plopped off. So we're going to take the V0 and minus V8. So this is going to be 12,500 minus 2,097.15. And again, I'd rather use an unrounded figure. That's how much that, and so that's how much that system has decreased by in 8 years. 8F.3. How many years will it take an investment of $4,000? So how many years? We need to find time here. Paying compound interest of 6% per annum to grow above 6,000. So we need more than that. So the initial is V0, which is 4,000. We can get a lovely R value here of 1 plus, and the rate is 6% per annum. And so this is equal to 1.06. So what we can do here is we've got our initial amount, and here's our recurrence relation, which will be 1.06 Vn. And what we can do is we can find out, you could have done this using the solve function, which we did a few videos back, but I think the sequences option will be the best choice. So I've just converted that recurrence relation into the sequences option. And you see here, we've got the A0 being 4,000, we got AN, we've got 1 plus 6 over 100. And now we just need to graph that, or I say graph that, we need to fill in the columns. So we're looking for, each one is a year, we want it more, the investment to be growing bigger than $6,000. So the first time it hits over $6,000 is after 7 years. So therefore, V7 or 7 years. 8F.4. A jumper making company purchasing a new knitting machine at a cost of $35,000. It has an estimated value of $5,000 after 10 years of operation. If the value of the knitting machine is depreciated using a reducing balance method, what is the annual rate of depreciation? Write your answer correct to 1 decimal place. So our initial amount is $35,000. It's a reducing balance method, so that means that our R value, so I'll just use a red to highlight that, is going to be 1 minus some sort of rate over 100. Have we got a little rate over 100? Oh, we need to find the annual rate of depreciation. Oh, that's very interesting. So we actually don't know what that little R is. Great. Write the answer correct to 1 decimal place. I have been told it has an estimated value of 5,000 after 10 years. So when n equals 10, we know that Vn is equal to 5,000. So what does that mean there? What that means is that if I was to write that as a rule, it would be, if you might remember, the rule would be Rn times by V naught. So if we fill in what we've got 5,000. We don't know what the R value is. We've got a little power of 10. And then we've got times the initial amount, 35,000. So we can also rewrite that to actually have an R in there, 1 minus little r over 100 over 10 times 35,000. So now it's time to use the solve. So what I'm going to do is I'm going to bring up the old CAS. We're going to go to the main menu. So now I'm going to enter this into the calculator and in using the solve function. So I've entered into the calculator and I've got two possible values. One of them is 17.6828746 or 182.3171. Well, we don't tend to use percentages that are greater than 100%, so we'll go with that first one. So to one decimal place, the R value will be 17.7%.